Yeah, as a background. So why did we create LMOS? Of course not because we just had fun. We needed to create the digital assistant of DT. Yeah? So basically the digital assistant which is available in multiple touch points at DT. So it's integrated into the web page, it's integrated in the mobile app. It's also integrated into WhatsApp or Apple Business Chat, and nowadays also into the hotline. And we've seen that the current or the old solution of our chatbot was not sufficient in natural language understanding and generation. So we needed to look into new topics. And then 1 year back, the large language model showed a lot of potential. So we started the new project, which was called OneBot. So what was the goal of this project? We wanted to create a chatbot which is not only deployed in Germany, but it's deployed in all countries. We call it NATCO, so national companies of DT. So it's already live in Germany and also in Austria. And next one is Croatia and then Czech and so on. So we're not only creating a chatbot which needs to understand German, but a lot of different kind of languages. So a lot of challenges we are facing. And as mentioned here, it's a multi-channel bot. So we do have different requirements per channel, which is quite important to understand. And so in voice, for example, in the outline, you want to have short, concise answers. They shouldn't contain links. In the web, you might want to generate responses which are in a way structured that the UI can display UI widgets. So if, for example, in our digital assistant, you can ask, what is my current bill, or why is my bill so high in August? Then with Arc, as you have seen, we are able to, first of all, call tools which can load the bills of a customer. Of course, the customer usually needs to authenticate itself when we load sensitive data. But then we can prepare the data in a way that the channel wants to have it. It means in WhatsApp, we can basically just generate natural language response, but on the web, we can generate a structured JSON response so that the UI can generate nice widgets and sliders and so on. So more complicated. So yeah, when we started the project last year, there were no established patterns or frameworks around. Even the open source frameworks like LangChain weren't really production ready. So we had a look at them also in the JVM world. There was LangChain for J, a clone of LangChain. There was Llama Index, but none of them really had a state where we said, okay, we can make use of it as it is and deploy it into production. That's why we decided to develop our own solution. But also because if we looked at our skill set of our team, most of our developers had been a background on the JVM, Java, and Kotlin ecosystems. So training them all in Python didn't make sense. And we started to use Python in the first proof of concept in LangChain. Unfortunately, it didn't perform well with a lot of load. So we decided to switch to JVM and make use of our skill set in distributed computing and develop a new tool based on the JVM and Kotlin. So there's an interesting book, Society of Minds. I know Arun likes it, from Marvin Minsky. Unfortunately, I haven't read it. I think I need to do it. But it basically explains the ideas which we had when we created LMOS. We were sure we need to create agents, but one agent is not sufficient. One agent is not really much intelligence. So you need to create multiple agents to create a really smart, intelligent system. So how do we start? We knew we want to create agents. So as Pat has shown, these are our entities which can process natural language and return something, like we call them agents, which are specialized on a certain domain. So we created a billing agent by a team as a microservice or as an individual service, which has knowledge in this billing domain at DT. It knows which APIs are available, which data is available. It knows how to connect this data. So one team can concentrate on the billing agent. Then we had another team which was concentrating on frequently answered FAQs, frequently answering questions, ask questions, thank you, which was more of a static RUC use case. So this was not personalized data, so you don't need to authenticate yourself. It was data which was available on the website or somewhere else. How do I cancel my contract, or when is the new release of the new iPhone? So such kind of data. So we started with RAG use cases. So we also have an LMOS, something like a vector database and embeddings and similarity search, that's for sure. But we have seen as soon as you want to get real time data about your bills, you need to query APIs. So this is how we started. So as said, in September, we had this alpha release based on LangChain, Python. As mentioned, we saw the performance is not good. We don't have much experience in Python. So in October, we started to build our, what we call a multi-agent modulith architecture based on LMOS. So we started to build a multi-agent system where all agents running in a single service, let's say. Yeah? So similar to how LangChain or Crew AI or other kind of frameworks work. They are no microservice frameworks. Huh? All the agents are running in a single Python process and threads. So this is also how we started, but we quickly saw this doesn't scale well. Huh? So if you're now independent teams working on different domains, they cannot all work on the same code base. We need to split them up. So in February, after we have released our first RAG bot, chatbot in production, we needed to work on billing use cases, sales and ordering use cases, and here we quickly saw that we need to call APIs. So in OpenAI, they're called tools. Basically, a tool is a set of APIs or functions you can call. This is what Pat has shown you in Arc. This is one of our solutions. Back then, we also had a second solution, which I will also introduce you to later. In May, after our initial solution, we saw we need to create a higher level of DSL, as Pat had shown, that developers don't need to care about the underlying infrastructure or details. They want to have a higher level kind of language they can quickly use to create new agents. Later I will show you how the code looked like when we started, and then you might see the difference. In July we started something, a test, Falcon 9, because we like SpaceX, a test with Arc where our developers needed to implement use cases. So we tested how many use cases, let's say reading billing information or changing the bill address or changing the IBAN. These are different use cases which we needed to implement. So how quickly we can implement new use cases and deploy it in front of the customer. So basically we have been able with LMOS and Arc to really deploy, develop 12 use cases within 12 days. So that was a huge improvement compared to how we started. And in September, we started to build our LMOS cloud native platform, which is also now open source. And this will introduce you a lot of new concepts, which I will show you. So some stats, as Arun has mentioned, we are in production. These are old stats. So we have answered a lot of more questions and sessions in production. Of course, using LLMs, it introduced some risks. It's not that deterministic, means, as you can see here, there's some sort of risk rate. LLM still hallucinate. We have some sort of solutions in place in LMOS and Arc, like self-evaluation, self-assessment, to reduce such kind of risk, but it's still happening. But the main goal of the digital assistant was to reduce the amount of calls in our hotline, because it involves a lot of costs and people. So as you have seen, we avoided like 300,000 agent handovers in that time we measured it. So 40% less agent handovers means the bot was able to answer the questions of the customer and did not forward the customer to a real human. This was the success story. This speaks for itself. So over the time, we definitely improved the time we needed to implement new agents and use cases. And with LMOS, which I will introduce you now, we are also able to more quickly now deploy agents in front of customers. with canary release strategies. I will show you how we're doing it with LMOS. So now we'll switch to a different presentation. Okay. So as mentioned, people are asking us why we called it LMOS or operating system. I mean, Arun said a lot of it, but when we started, we took the inspiration from our operating system and thought basically agents are like applications. Huh? So we want to implement applications like on operating system, and developers shouldn't really care if they implement applications what kind of CPU or hard drive is used underneath. Huh? So what kind of model is deployed or what kind of infrastructure is used to store long or short-term memory, which is also necessary in chatbots. So we created this abstraction like an operating system or kernel, which was also LLMOS kernel, which we also will release soon to the open source, but Arc is also making use of it, which abstracts a lot of the complexity, how to interact with LLMs, how to interact with caches, for example, short-term caches, where you want to store information about the conversation history, and so on. And so we are providing libraries and APIs for agent developers, which are then making use of. So Arc is making use of these libraries and APIs internally. But as a developer, you not always need to have a look at this. The second inspiration is from our history. So many of us worked multiple years in the smart home and IoT domain. And what we are seeing here right now is something similar what was happening in the smart home domain, that there are so many different ecosystems, devices which don't work together. As a customer, it's really a pain to integrate all the devices in your home or in a building, and they just don't work together. And you see the same in the AI ecosystem right now. There's so many new frameworks in different languages. There's so many big players like OpenAI, Microsoft, Google heavily investing into it. And none of the ecosystems are really meant to work together. So you need to choose one, and then you'll have a vendor lock-in. But what we are also seeing, even in DT, is an explosion of AI agents. We are not the only one who is developing an AI agent. In a different department, they are now developing an agent which can solve technical support questions. We don't need to re-implement this. We can integrate this bot into our system, if it would be possible. But they are developed in different languages, on a different platform, maybe on different provider at all, maybe bought by someone. So it's not easy to integrate them. And we already see this pain. We don't want to re-implement everything. So what we need is for agents, first of all, is this a layer where you can describe the capabilities of agents. So like in a smart home device, there's some sort of description, like a metadata, which describes the capabilities. What is this kind of device? Is it a lamp? Is it a smoke detector? Is it a ambient light sensor? But in agent, it's similar. Is it an agent which can answer billing-related questions, or is it an agent which can fetch data from a website, or is it whatever an agent which is using backend systems to solve technical issues and automatically restart your router or whatever to solve your issues? But in order to discover all the agents which are deployed somewhere, you need some sort of metadata descriptions. And here we learn from what we have experienced in the smart home domain, in IoT domain, and we want to apply it in LMOS for multi-agent systems. Nevertheless, if this agent is developed by us with Arc, or if it's an external agent which we want to integrate into LMOS, if we have this kind of description, we know what this agent is capable of. And then you also need this find layer. So where's this agent deployed? Is there some sort of registry where agents can register themselves? And you can dynamically now search for agents in a global network, not even on a local network in your data center, but even on a global space, you can try to discover agents and see if they make providing capabilities which make use for you to use it. And then on top of it, of course, access layers which you need. How do you access it? How is it protected? How you can access tokens to use it? And what LMOS also wants to achieve is now the compose level. Huh? So how can I now compose all these agents into a single unified system so that I have a single user experience in front of the customer? I want to have one single chatbot in the customer, not 3 or 4 or 5 he needs to use. And yeah, as mentioned, we quickly saw we need frequent deployments, and this is only possible if you don't build a monolith. Every agent basically needs to be an independent entity which can be deployed to a subset maybe of a customer base. Maybe you want to roll out a new version of an agent to only a subset of the customer, like 10%, or maybe only to beta customers. And you need a system which is providing you this capability to do canary releases and a smooth rollout. Similar to parallelism. So with this kind of microservice agent architecture, our teams can work in parallel on multiple agents, develop them, test them without interfering in the code base. Reusability is a topic which you will see in LMOS now. We built reusable prompt flows and steps which you can reuse while developing an agent, so that you don't always have to implement this yourself. So you could think maybe in the future there's some sort of marketplace or some store where people can provide reusable components which you can then use in your agent itself. And yeah, as Pat also has shown, we roll out our agent to multiple countries, NatCos, and channels. Do you now need to implement one agent per NatCo and channel? Then you have an explosion of agents and services you need to manage and roll out. Or is the agent that dynamic also in the system prompts and the APIs it can call, that it can decide based on the tenant? Is it now running in Germany? Is the request coming from the hotline or text? Which kind of prompt it needs to generate so that the response is expected? So yeah, now coming back to what is LMOS actually? Yeah? So LMOS is now a tool set, we can say. So it's the foundation of LMOS is Kubernetes. So first of all, LMOS is deployed in the cloud for now. And it's making use of Kubernetes, of course, to deploy the microservice, the agents, to scale them up. We're using issue mechanisms for traffic management to get insights and how much traffic is running on the system, how do services communicate with each other. So there are other nice open source tools like Yali, where you can then see really the dependency diagram of the communication between services, and you can see what is going on your system. But this is not sufficient. We saw very fast that Istio is providing traffic management, but it doesn't work for agents, because agents need to route questions based on natural language processing. Yeah? So you need to understand the question of the customer to decide if this question should be routed to a booking agent, if it should be routed to a FAQ agent, or to another agent. And this even dynamically based on the configuration of a tenant or a channel. Because in Germany, let's say we roll out we have rolled out all features in Germany, and we're starting in Austria, but Austria doesn't want to start with all use cases and all agents. They want to start small, maybe with the FAQ agent and the next billing agent, and maybe even with a subset of the capabilities of a billing agent. Maybe billing agent has a lot of capabilities. It can answer your questions regarding your bills. It can change your IBAN. It can change your billing address, but you don't want to roll out all these features, only a subset features of the billing agent. And this is also something you need to be able to configure. And this is where LMOS, the router, and the LMOS operator come in place. So depending on what kind of agents are currently deployed in this system, we know which capabilities are there available based on the descriptions of the agent. And now you can configure for a specific tenant, for a specific channel, what kind of capabilities these agents are providing should be active. And based on the configuration, the router now gets a router configuration to understand hey, there's a question, and this is the subset of capabilities I can support, and now I'm able to route the question to the correct agent. And as seen here, Arc. Arc is our internal framework which we're using to develop agents, but we also want to say, bring your own agent. If you prefer Python, LangChain, why not? Develop it in Python, deploy it as a microservice. You just need a thing description, which explains the capabilities. Maybe implement a slide communication layer, which is in our case standardized. We will also release this soon, that you can quickly change the protocol of your agent from HTTP to MQTT to AMQP, whatever you want to do, we support it. And yeah, so that's basically what I wanted to say here. I've also briefly discussed this already, that we are standardizing now with LMOS based on open standards. So we work together with W3C on such kind of standards to use it to describe the metadata and capabilities of agents, which are then used to dynamically discover agents, not only on the global network, but also on the local network. You could basically use an agent, run it on your device at home. It uses MDNS to propagate its capabilities like a smart home device, and you could be able to find it via your phone and directly use it. No need to involve a cloud solution if necessary. And yeah, so in LMOS itself, as said, it's a multi-agent system. So we have this concept of a supervisor agent, which is the first agent, which is retrieving a request in our system. It can make use of our LMOS router component to then understand which kind of agents are currently available and configured, and then route the request to the agent. But the supervisor agent, which we see here, in our solution, also doing pre and post processing steps. So before you route something, you probably need to read the previous conversation history. You can't just route the last sentence, not like yes or no to the agent. You need always the full or maybe a subset of the conversation history and send it to the agent. And then, of course, very important at DT is anonymization. We are not allowed to send any personal data to a large language model which are deployed in Azure. So we also developed AI services named entity recognition, which can understand certain entities like names, addresses, from the question extracted and replace it with placeholders so that the LLM never gets your private data. And of course, then after the agent has created a response, the response might contain the placeholders. We need to de-anonymize it again, do some more, store the answer in the conversation history, and send it back. Should I go faster or a little faster? Yeah. So I mean, this was how the agent looked like at the beginning. So you needed to write a lot of code. You have been able to define what we call prompt flows. So usually it's not just a single prompt against an LLM to answer a question. You needed to chain multiple things. And these are reusable steps. So anonymization was developed once and can be reused then in a conversation, and you can chain them maybe sequentially or parallel. And then the router might forward this to a billing agent. The billing agent is able to now read customer information, and like we have seen in Arc with tools. So it's calling HTTP APIs of DT to read your profile information, understanding what kind of contract you have, a mobile fixed line contract, and then generate an answer based on your question, do some self-evaluation, which is very interesting and to reduce risk. It's taking the context, its own answer, and sending to different model to do the self-evaluation. So in LMOS, you can pick a different model on every step. You're not bound to a single model. We have seen for some steps you can use models which don't need tool support. They are less expensive, faster latency, and for others you need more and better models. And I probably, because of the time, might skip it. This is how you can develop reusable steps and then bring it back into some sort of library which can be reused by others. So you can access, it's basically a chain of steps. Every output of the previous step is the input of the next step, and so on and so on. So you can always access the inputs of the previous step and do something smart on it, like prompting now the LLM and providing a set of functions and then return it back. But you saw it involves a lot of code. You still need to develop a lot of code. That's why we thought we developed the ArcDSL. Will show it here because Peter had showed before, which abstracts most of the complexity. And again, I want to show this. As Pat has mentioned, you in Arc, you also get a command line interface extension with which you can install basically a ready application and then run your Arc DSL in it, and it automatically starts an application which brings everything with it, also metrics. So you can directly deploy it on a Kubernetes environment, and you get metrics out of the box for requests, latencies. It's also logging everything important which needs to be stored on a log management system to get some transparency what is actually happening. And then we have the UI, what Pat has shown, to quickly iterate and improve your prompts. What time are we? Yeah. So as at in LMOS, we currently have this concept of tenants for our NATCOs. Could also be B2C, B2B, or just a single tenant, whatever you need. And you can define different kind of channels. And the channel is basically a group of agents. This is the way how you can group agents. We call it channels because of our background. Maybe we will rename it at some point in time in our open source project. But it's a way how you can group agents by telling what kind of capabilities do you want to support in this channel. And agents are providing capabilities. So a channel is never pointing directly to a specific agent in a specific version. So I don't want to use billing agent in version 1.00, because how does it work if you redeploy it and the agent channel is broken? No, you can define which kind of capabilities you want. A single agent can provide multiple capabilities, not only a single one. And you can even just reference a subset of the capabilities. That means we might have a tenant like Germany, which has two channels, which might be the app and the web channel. The one app, the app channel owns only, this is of course not a real example, but the app might only support retrieving weather forecasts, and the web channel might support multiple use cases, weathercast and page summarization. You want to have a question?
Yeah, so the interesting point you mentioned about capabilities being this, let's say, intermediate layer.
Yeah.
Is capability just a description of an agent essentially, or is it more than that?
Yeah, exactly. So basically a capability is a description. What can I do? This kind of description can also now dynamically be used in the prompt, in the routing configuration, so that the LLM understands what is this agent capable of. And it has a version. So it means whenever you develop an agent, every capability has its own version and can be versioned.
And what's the advantage to having the agent directly?
So let's say I will show this in a second, but let's say you deploy a new agent version, which is providing capabilities in certain versions, but only one new capability in a new version, and you deploy it to a channel. This agent can answer every other capability, but also the newest version. And if you now define, you can have multiple channels. I want to show this. No, not here, but you might have now a channel which is the stable channel, means every production customer will get this channel, and then you might have a canary channel, and you can configure in LMOS that only a subset of customers, like 10%, should be routed to the configuration of the canary channel, and the canary channel might point to a new version of this capability, and then can dynamically look into the environment, which agent and which version is supporting this capability, and then dynamically is using this agent if it's providing the new version of the capability. Yeah. So we have implemented sort of resolver and operator. Concepts might be similar to OSGI, so you might look it up on the web after meetings. So OSGI is a very interesting solution for requirements and capabilities. And I think after you read this, that makes more sense.